Greetings, future fossils. Welcome to episode 163 of the podcast that explores our place in time. As a bit of hopefully helpful framing for people new to this show, when I say our place in time, what I mean is here at this moment of great transition that is challenging all of the incumbent frameworks we use to understand this world, including the dualist distinction between self and other, as well as other conceits of modernity such as materialism, or the notion that the world can be rationally known. Spend a lot of time on Future Fossils talking about the philosophy of post-humanity, which, as I understand it, springs out of the revelations of ecological science to offer agency to the non-human world at the same time that it fatally challenges any kind of human exceptionalism and even the very category of humanity. Where the rubber hits the road for us in this conversation is in examining new research on the fungal ecologies of our soils worldwide, research like that being conducted by evolutionary biologist Toby Kiers, and the new decentralized economies springing up from innovations in computer technologies, namely the blockchain and other distributed ledgers that enable new forms of money and value accounting and provide novel affordances for coordination between human beings, computers, and other systems. Bitcoin evangelist Brandon Quittem wrote a very deep and interesting 4-piece article on how Bitcoin is essentially a mycelial network. I will link to that in the show notes. Brandon introduced me to Toby, and so the three of us had a fascinating conversation, which, however, I have to admit was somewhat compromised by the fact I only got 2 hours of sleep the night before. Such are the risks we run in trying to surf the accelerating wave of change. Nonetheless, I think the discussion that follows is an interesting case study of what happens when three people with very different priors come together in a mutually illuminating discussion that triggers new insights and stimulates new questions for everyone involved. And I hope you get as much out of it as we did. But before we dive in, I just want to thank every single person who has been supporting Future Fossils on Patreon, leaving your 5-star reviews at Apple Podcasts, leaving crypto tips, etc. After 5 years of doing this show, I am finally at the point where I acknowledge the desperate need to hire help to edit and to publicize this program. And if you believe in the work that I'm doing, if you're getting value out of these conversations or out of the copious amount of time I spend in our Facebook and Discord communities, then I hope that you will back that value assessment and help me reach my goal of doubling this show's monthly subscription income so that I can hire help, get back to recording more episodes, spend more time with my family, and allocate more energy and attention to coming up with creative side projects and make Future Fossils the most excellent, wonderful, helpful thing I possibly can. For now, what that means is ramping up the schedule of the Future Fossils book club to monthly, along with asynchronous book club discussions in the patrons-only channels of the Discord server. This Sunday's live video call, we discuss Australian science fiction author Greg Egan's completely prophetic 1995 novel Distress. And next month, we're going to get into Annalee Newitz's new book, 4 Lost Cities, A Secret History of the Urban Age. Both of these I'm immensely excited to discuss with everyone. A special thanks this week to all of the new patrons that have signed up since the last episode dropped. Amanda Wolf, John Sheldon, Rob Heather, Jay King, Hugo Morris Adams, Josh Linz, Matt Ismay, and Florian Liu. Thank you all so much, and thanks to everybody who has been helping me keep this show alive and growing. You are the mycorhizzal network feeding the roots of this tree so that it may grow tall and mighty, providing a fractal crown of niches to support an entire ecosystem of cool perspectives and discussions. So that's enough hyperbole and BS for now. Once again, check the show notes for all of the resources that we discuss in this episode, including links to the Facebook group, Discord server, and my own recent efforts in minting non-fungible token artwork. Thank you for listening. Enjoy the show, and we'll be back with another weird and wonderful episode of Future Fossils in 2 weeks. Did you hear about that guy that injected psilocybin mushrooms into his bloodstream?
No, wow. No, that's not a good idea. How did it go?
They were growing in his blood. There were spores started to sporulate in his blood. And they were like, what the hell were you thinking, man? A couple of weeks ago, it was a big thing on social media. Everybody was making fun of the guy who was, it's like, oh, clearly he was a heroin user that just thought he was going to get higher if he injected mushrooms.
Wow, I'll have to look it up because I'm not aware of the story.
Yeah, no, it's messed up, but we don't need to go there.
On that note, I saw, obviously we have a thermal exclusion zone, right? We're too warm for most fungi, but I saw some process taking place where if we warm up the planet, it will essentially force fungi to adapt to warmer temperatures, which could theoretically make a larger subset of species being able to attack us. Is that true?
Yeah, in our blood, they've already started finding them. They're finding all kinds of new fungi that can attack our blood because the temperature, they think that they're adapting to the warmer temperatures outside, and now it's getting more closer to the temperatures of our own bodies. So we're gonna be facing a lot of attacks in the future.
So we're mushroom food cool, after all.
Yeah, fungi are cool though. Let's not get into the pathogens because they're
actually, this is great because Toby, you may not know this. Brandon, I think, has a slightly better sense of this going in. How well do you two know each other? Was this just a lark? Yes.
It's a lark.
Okay, so
a friend of mine just said, "Hey, Brandon, I like what you write about mycelium. Have you seen Toby's work?" "No, I haven't." "Oh, wow, I love Toby's work." And then I said, "Hey, do you want to do a podcast?"
Cool.
And now here we are.
Well, thanks for letting it be my podcast. Future Fossils tends to be, I was just telling my friend, I am a tightrope walker over the chasm of ambivalence. Like everywhere I go, I feel two ways strongly about things, right? So I am going to both advocate and viciously criticize things just because that's how I am. And maybe that's a little bit easier for the Dutch than it is for the Americans. I don't know.
I'm American though by birth.
Are you?
So just to
okay.
I am. I grew up on the East Coast and then in California, but moved to Holland about 15 years ago.
Interesting. All right.
Yeah.
Well, shall we then? Or do you have any questions before we start?
No, I'm really excited. I mean, it's a great opportunity. So we don't get great training as scientists in terms of using language that's accessible.
Oh,
so please,
me,
if something is not clear, then just stop me mid-sentence and make me clarify. Yeah, I think the same thing might be with economists, but I don't know.
Yes.
Well, it's my job to make sure that scientists and economists are understood. So
fantastic.
All right. Toby Kiers, Brandon Quittem, welcome to Future Fossils.
Thank you very much, Michael. Excited.
Thank you. It's wonderful to be here.
So this self-organizing conversation emerged out of a seed crystal of interest in the analogy between evolutionary and ecological dynamics and economic networks. And this morning, Toby, while wrestling my toddler, I watched your excellent TED Talk on the mycorhizzal networks and how they function as a kind of marketplace between organisms. And, Brandon, I've been enjoying your writing on the analogy between Bitcoin and mycelia. So I would like to explore think of it like a sticker, right? Like you place a sticker and there's a little edge of the sticker and maybe you can peel the edge. Yeah, I'm looking for where in this analogy we can find the edges that peel. What doesn't work about this analogy? And then also where the adhesion is perfect, elegant, and beautiful, and it really, really sings. And we can say, that's insightful. And that gives me a whole new understanding of this process, whether that be, you're looking at digital economies or whether you're looking at evolutionary relationships over deep time. So it's going to be a give and take. And I think what I'd like to do is start with Toby and please introduce your research to people a little bit and how you came to thinking about things in this way as you do and as you discussed in your talk.
Perfect. Yeah, thanks for the introduction. So I'm an evolutionary biologist by training here at the Free University in Amsterdam. And our lab really studies the evolution of trade in nature. So we're interested in organisms that form partnerships, very intimate partnerships, right? These are called symbioses. And then we ask why they trade resources and how each partner benefits. And I think most interestingly, what causes these trade relationships to break down. So probably the coolest part is that we try to identify the cheaters in nature, right? These are the ones that swindle their partners, that, take more than their fair share. And I think nature really is full of cheaters. So in our group, what we do is we create situations in which we sort of force partners to cheat. And then we study how the other partner reacts. And I think the real workhorse of our lab is the symbiosis between plant roots and a very important and really globally ubiquitous underground fungi called arbuscular mycorrhizal fungi. It's quite a mouthful. But basically, we're studying these underground trade networks where the fungi basically collects like phosphorus and nitrogen, all these important nutrients from the soil, and it trades it for carbon from plant roots. And so what we do is we sort of develop these tools, really cool tools to be able to track how organisms without brains actually make trade decisions. And I think for me, this underground really, it represents this this very vast unknown. And there's so little that we know about it, but we're really starting to understand these trade. So we're studying these arbuscular mycorrhizae, and we're trying to actually track how organisms trade and how they make decisions without brains. And I think that's quite interesting link between our work, Brandon and I's work, is actually trying to understand how systems make decisions.
Yeah. So how did you come to, it seems somewhat natural and effortless to think about these things in these terms, but I'm curious about, for you, how you came to deciding to research this in this way.
Yeah, I think actually people tend to think that we're using economics as an analogy, right? But this is, I think, where I need to correct them. So it's not necessarily about making analogies. I use economics as a tool, right? It's an analytical tool to be able to make predictions. So, for example, if we know that the environment contains this much nutrients and there's this many partners, then we predict that the partner will act this way, right? And as there's more resources available, maybe it'll get less of a value for those resources. So really, we use economics more than just an analogy of trade, but really as a predictive tool.
Yeah, that makes a lot of sense. So I have this other podcast that I do for the Santa Fe Institute, Complexity. And on that podcast, I got to talk to W. Brian Arthur of Stanford and Xerox PARC, who wrote this book, The Nature of Technology, which I will bring up later in this conversation. We were talking about his reflection on the history of a field of research called complexity economics. And it was basically this idea of using non-equilibrium statistical physics and ecology and putting those into the economics models. Because I think, if I'm understanding you correctly, I would agree that it's not that this is an analogy simply for the purposes of helping explain this so much as it is that, in a way, like economics itself is an analogy for the way that resource flows occur already all around us. And this was something that popped into my head in college when I was introduced to the idea of ecosystem services and reminded by my professor that the quote unquote economic value of things like the carbon cycle and the oxygen cycle are orders of magnitude greater than all of the money in existence. And so our economic models, therefore, and all of the value that we actually measure and can exchange in human economies are like a pitiful, measly subset of the actual value that's being exchanged and the actual measurement and intelligence that's on display here.
Yeah, I also think it's interesting what you said about flows, right? I really think that what we're trying to do in my lab is that we're sort of part of a new generation of biologists, right? That's moved on from studying biology as the biology of things to really studying biology as processes, right? So biology is now about studying organisms as processes. So if you look, let's say, at a fungal network, right, which is incredibly complex, you can try to interpret the body of that organism as a means to actually guess the structure of the environment. And I think you can do that in economics as well, right? You're trying to understand trade to get a better hand on the structure of the environment. So I think that's one of the things that we do that's really important. And the other thing that we're really pushing is that there was this old view that microbes, right, they were really standalone asocial organisms. And we didn't have much respect for how they worked as systems. But we're really pushing this new view, right? Where microbes, they're social actors, almost by definition, right? They're forming these very complex networks of coordinated behavior. And I think this work is sometimes controversial, right? Because people don't imagine that fungi can exhibit behaviors. Right? But I really think that that's where they're wrong. There's no cognition, right? There's no brain involved. They're enacting strategies that are shaped by natural selection, but they're still exhibiting these behaviors. And so what we're trying to do is kind of unpack how you can understand these strategies and these behaviors and how they interact with an environment. And I think economics there is a really useful tool that goes beyond just being an analogy.
Excellent. So that's half of it. And then Brandon, I'd love to hear you talk about your thinking on these matters and how you came to be here in this conversation.
Yeah, definitely. Thanks, Michael. And I love what you're saying there, Toby, just to piggyback off that before I go into some sort of an intro. But what I'm hearing is that if we use the soil ecology as our sort of petri dish here, resources are limited there, and there's many organisms competing to reproduce. And that sort of limited resources or scarcity creates a competition, and trade is beneficial in that environment. So over the long evolutionary history, the organisms learn to trade for their own benefit. However, trade creates wealth. It is a 1 + 1 = 3, which allows some organisms to specialize and then, trade with what they're best at. And it sort of creates a more vibrant ecosystem due to the trade. And I think economics is sort of a loaded word today because people feel that the economic system is not working for them. However, I think it's more of a hard facts thing. Like it's just allocating resources where they're most valued. And so your research really inspired me to dig deeper into my own assumptions here. And I'll lead that into my background. So I'm an amateur mycologist. I don't even want to use the word mycologist. I'm just a mycophile for a decade, starting with foraging and cooking and many other different paths there. And so I take lots of liberties with the mycology in my writing, and I'm aware of that. But I find that the analogies are helpful. And sort of my mission here is to combine the worlds of mycology and Bitcoin, or you can say like the future of economics or network-based money, or whatever we want to call this transition humanity's going through. And so, yeah, I just did a lot of research, put some ideas together that spread around quite well. And I've probably turned on thousands of people who are interested in Bitcoin into mycology, which is kind of a secret motivation for me here.
So I came into this conversation loaded with a bunch of like graduate level questions for the two of you, but I think it's important to start for the people who have not read the things that the two of you have written, have not seen the talk that you shared, all of this stuff is in the show notes. And like most things on this show, I guess if you're listening to this, you're probably used to just getting to sort of backfill and make sense of things. Like, as you know, just go to the show notes and look at all this stuff. It's great. But I'm going to try and be more responsible in 2021 and provide more exposition. So, Toby, can you talk a little bit about the ways in which mycorrhizal networks actually do perform the kind of what I think of as computations? These transactions, like you said, are about inference, right? Like it's a way to predict features of the environment and features of the dynamics of the relationships between members of that environment. And so, like, could you talk a little bit about this relationship? You're quoted in the New York Times as saying, where some scientists see a big cooperative collective, I see reciprocal exploitation. Both parties may benefit, but they also constantly struggle to maximize their individual payoff. So, one of the running themes on this show is an interrogation of the concept and the conventional boundaries of individuality. And I think this would be a lovely place to get into some really deep stuff, starting in a very elementary fashion about what you're observing these fungi do, and then what that tells you more broadly about the relational nature of evolution and of economics, if we can. That's a lot, but I trust you.
So I jotted down that it seems like 3 separate questions. So I'm going to start with the easiest ones. And that's cool. Just about what we found, right? The kind of experimental work that we do and the things that we found. So basically, you have a symbiosis, as explained, formed between plant roots and these big fungal networks. And what we do is we tag nutrients, and we can tag phosphorus with these quantum dots, as they're called. They're these nanoparticles that fluoresce in really bright colors when hit with the UV light. And tools like this and many other tools, some that are less technologically advanced, they allow us to kind of look at trade decisions. And I want to focus on trade decisions from the fungal point of view. So what we do is we set up very simple experiments. For example, we connect a fungus with 2 plants, and then we'll grow one in the sun and one in the shade. And then we'll say, okay, well, we assume that the plant growing in the shade has less sugars, less carbon to give. Now, the fungus is completely reliant, and this is really important for all our discussions. The fungus is completely reliant on the plant for all of its carbon, for its fats, and for its sugars. It cannot live without host roots, right? So this is really important. The fungus needs to make the right decisions, basically, to be able to get this carbon. But what we find is that the fungus is good at discriminating among plants growing in the sun and the shade. So it tends to allocate more of its phosphorus to the plant growing in the sun. It's giving more resources. It's discriminating among partners and sending more resources to the better partner. Then we can do even more complex experiments by, for example, adding in more fungal competitors. And we can see that they trade differently depending on how many competitors are present. We can see that the fungi are good at, let's say, artificially inflating the price of nutrients by taking it up into their network and storing it, right? Storing it until they get a better price. And we find that, for example, plants will invest in the network in different ways depending on how many other plants are connected in, right? These are all examples where we see that the fungus is able to choose a partner and then allocate its resources to the best partner. And that's basically the hallmark, the foundation of economics. And why we use this word reciprocal exploitation, right, is it basically it recognizes that the fungus itself is a trading partner, and its goal, and this is because of natural selection, because of evolution, is to maximize its gains. And so this fungus has been around for 450 million years. And over time, it's really evolved these very clever strategies that allow it to play the market, if you will. So what we can do is basically just set up experiments, we can manipulate conditions, and then we can study fungal behavior. And over the last decade, we found that fungi are I would say, a lot more clever than we had expected initially.
So, Brandon, how does that, obviously, you've written extensively about this. How do you see that? Where's the relevance, rather, for you with Bitcoin and with it sounds to me, reading your work, like you're a quote unquote Bitcoin maximalist. That you declare very clearly that you stand on the side of Bitcoin being capable of absorbing the qualities, the innovations of other cryptographic currencies and so on. Maybe that's not a useful distinction. I don't know. But how do you see this related to the digital economy and what we're witnessing here? And then how does that differ from the way that you understand economics as it has been practiced for the last few thousand years before Bitcoin?
Yeah, totally. I think that's the right framing right at the end there, Michael, where what I would say is how we do economics and how we run a financial system as a species today is very much a command and conquer or a central processing unit, ivory tower. We put the smart people at the top of the pyramid and they supposedly make decisions. And so that type of system creates a lot of fragility in the system. And, it leads to all these downstream consequences that make the game unfair for normal people. It sort of creates incentives where powerful people, instead of trying to create value for the world, the incentive is actually to get really close to the political elites or the central bankers as it's implemented today. And that creates, crony capitalism or whatever we want to call today's version of economics. And I find that to be a really poor system. It constantly breaks. And every time it breaks, we build a new one. And that just builds up wealth inequality. And it's also a very discriminatory system. So it leaves certain people outside of the monetary network. For example, around 2 billion people don't have access to financial services. And so we have all these people that are sort of disenfranchised. And again, from a systemic standpoint, I like to think of our current fiat monetary system as a monocrop, right? It's susceptible to disease, it's unsustainable, it's hyper optimized, which makes it fragile in the event of a black swan or some sort of volatility shock. And to bring it to fungi quickly, we all know about the Panama disease, the Fusarium fungi, which completely decimated the banana population around the world because we just cloned a single species. And that's kind of how I see our financial system, right? One predator wipes out the whole system. And the way I see Bitcoin, it's an open monetary network. It's permissionless. Anyone can access the network. Anyone can build on the network. It doesn't care who you are. It doesn't even know who you are. Right? It's just an open system that connects the whole world to exchange value. And no one can say you can and cannot. And a system like that, it's highly redundant, right? Millions of people keep track of the ledger of who owns what on their computers. And so if you attack this network, it doesn't really matter. Like if you chop a mycelial mat in two, now you have two mycelial mats. And it's similar with Bitcoin, is where it's anti-fragile. And it grows incrementally, it's sustainable. It's the opposite of fragile. However, in that system, it accepts the short-term volatility. That's the competition. That's the world around Bitcoin affects the price very, very rapidly. However, what it does in exchange is it gets long-term systemic stability because there's no fragile points. And so I see Bitcoin as a mycelial mat underground trading. And anyone can participate as long as they're interested and they provide value to the system. That's kind of a high level view, but I think that's probably the right place to start.
Yeah, can I just jump in there? Because I think what Brandon said is really interesting. And, I think what Bitcoin does, this idea of decentralization, right? That's really what it comes down to. And decentralization is also incredibly important in these fungal networks. And almost the genius of Bitcoin, right, is that it's not this perfected, phenotype, but it's kind of, I think its real breakthrough was like putting together pieces in a semi-novel way, the way that you would through evolution, right? In a semi-novel, but not necessarily a perfect, but workable way. And this is this idea that actually perfection is the enemy of progress, as we say as evolutionary biologists. I think what we're seeing is that you've got these very complex systems of really interacting mathematics and protocols, but that they have evolved ways where they can coordinate, different nodes that could or could not be trusted. And that's the real power of decentralization, is actually trying to bring together different parts and still be able to make decisions. And I think that's a really, really hard thing to do, but if it works, it can be very robust.
All right, so I want to talk about networks, and so to fulfill the promise from earlier, one of Brian Arthur's main contributions to complexity economics was this idea of the increasing returns to scale, which is, network effects, right? And, to your point, Brandon, about anti-fragility, this is one of these things. Actually, I'm going to sound like a total, if I don't already, let's just throw Magic the Gathering in there, because there's some, Spore token Magic the Gathering collectible card games that the dynamics of those cards beautifully are that, you wound a creature and it generates more spores. And it's something anyway, that's for my friends in Austin. But I want to talk about this whole issue of resilience, robustness, fragility, anti-fragility, because we're looking at multiple different scales. And again, to your comment, Toby, about reciprocal exploitation, biology is full of these tricky framings where they give you an option. It's like, all right, am I going to frame the human being as the organism that's covered by skin, or am I going to frame it informationally as you plus your cell phone and the servers that are running your cell phone and the rare earth mineral mines? At what point do you draw the line? The point is, it's not a fixed point. The point is that where you draw the line depends importantly in some ways on the kind of questions that you're asking. So for me, my questions about you two and the ideas that you're holding are about, Toby, you talked a little bit about how the fungus works like a Robin Hood style approach. There's different narratives around this where we see it sort of generating wealth or affluence for deprived nodes in a forest network. It provides resources for plants that aren't getting enough sunlight. But to me, that seems like you're right it's not altruism, it's serving the system itself.
Well, let me be clear. So actually, our work does not find high levels of altruism. Our work actually finds that the fungi is very good at calculating where it's going to get the greatest returns and allocating resources or sending resources to that partner. And this goes against a little bit about what people, I think, in the public think of how these networks underground operate. They have been told, I think, a lot in recent years. There's been a real interest in how these networks interact underground. And there's been a lot of work suggesting that these organisms are helping each other and that they're sharing resources and that they're sending resources to, let's say, poor partners that are in the shade. And actually, when you study it on a very small spatial scale, we don't see those kinds of patterns. In fact, we see sort of the opposite. What we see, and this is why I use the word reciprocal exploitation, is that instead we see behaviors whereby organisms may be moving resources, but they're moving resources in a way that benefit themselves, not necessarily the forests above them. So in that sense, we don't really see forests as one big superorganism. Instead, we look at strategies of individuals, because that's really the level that evolution and natural selection operate. This doesn't mean that you don't see sharing, but usually if you do see some kind of behavior, it can be explained at the level of the individual rather than at the big sort of ecosystem Gaia level. And I think this is an exciting time for us in biology, because we're really starting to understand how these systems operate. And there's a little bit less storytelling. And I think people are getting, frustrated with that, but we're discovering such cool behaviors that we can now explain.
And to dig in there, Toby, I thought it was very interesting that the beginning of, I think it was the Quanta article, which sort of gave the high level overview in the timeline, where the Gaia hypothesis came out more or less during the psychedelic revolution or consciousness revolution, which would make sense that the idea would be it's sort of this underground sharing or community or communism type structure. And then you're more or less saying that, no, it's more like a market. Each individual actor maximizes their own return. And in that process of trade, they can specialize. And if everyone tries their hardest, that trade actually does provide value to other participants. And you've shown it in these very, I'll say, limited experimental settings, right, compared to an actual meter of soil or something like that. And I'm curious, I know you did a bunch of work in two-dimensional planes, more or less a petri dish, and you can show the fungi and the plants acting in their own best interest, et cetera. I'm curious if you've done further work on that and gone three-dimensional, if you have any sense on how that would translate from a lab to the environment.
Yeah, you really hit on, I think, sort of the major goal in the next 5 years, right? Really where we're trying to aim at is getting into these 3D systems and actually moving our work into the field. Because obviously when we set up these experiments, they're very artificial in the sense that, in nature, you've got networks, but you've also got bacteria on those networks, and they're using the networks to move back and forth, and they're secreting chemicals to benefit themselves. And then the plants are letting out chemicals because they're being attacked, and those chemicals are going down across the network. It's a massively understudied ecosystem, right? We really have no idea what's going on down there. So I think we can tell stories, it's kind of like a market capitalism, and other people can tell stories, it's like socialism, but really it's about getting down to the biology. And I think on that sense, all of the scientists are really on the same page, and we're just saying this is one of the most understudied, unknown ecosystems. And what are we going to find as soon as we go to 3D systems? What are we going to find as soon as we, what we're talking about is a petri plate with agar and a fungal network, right? As soon as we add real soil organisms, there are these amazing fungivores, right, that come along and they start chewing on the network, right? As soon as you have that into the system, how is that going to change trade? There's all of these complexities, and I think I'm going to definitely be the first to throw up my hands and say, okay, we really don't know. But what we can do with the tools we have available right now, what we see follows really the lines of natural selection and evolution, and that's that organisms are selected to maximize their gains. I'm a socialist at heart, right? One of the reasons I left America and moved to Europe was because of the economic system, right? But that doesn't necessarily mean I have to see socialism in the soil. I think that what we see in the soil is a lot of conflict, right? There's a lot of tension with organisms just trying to reproduce, just trying to get enough resources to reproduce. And that tension drives innovation, right? It's conflict that drives the system, that drives these clever trade strategies to evolve. Right? That doesn't mean that it has any bearing on our morals. It's just trying to understand how the system works.
So, at risk of invoking Terence McKenna's mushroom apocalypse here, I have to ask, because you're talking about three-dimensional networks, and I'm immediately drawn to conversations I've had with Jeffrey West at Santa Fe Institute about his work on scaling laws and biophysical networks. How he talks about the so-called finite time singularity. So there is I'm going to try and compress this into the shortest thing, which is that your cardiovascular system or the road network of a city, these are ways for the distribution of nutrients, right? But the difference with a city, what makes an ecosystem different from an organism, and what makes a city different from businesses and other firms growing inside of a city, is that it acts as a space within which recombinant social interactions are fermented. So innovation is built into chance encounters.
I think I see where you're going with this. And actually, it's something that I really wanted to talk to Brandon about. So maybe I can set it up in this way, because I have lots of questions about how Bitcoin operates. So the interesting thing about fungal networks is that you have multiple nuclei inside of them, and they're flowing all the time through the network. Now, these nuclei, right, they're the genetic information. They're what determine how the network grows, how it trades, how it reproduces. But these nuclei are not necessarily exactly the same. So you have to, just strap in, because it's kind of hard to understand. But imagine you had a right hand and that had a different genetic makeup than your left hand, and they're growing out in different ways. So, we think of ourselves as an organism, a single organism, and all our genes are the same. But if you go inside these arbuscular mycorrhizal fungal networks, they have hundreds, thousands of nuclei, but they're not exactly the same. Yet they have to work together to reproduce. They need to work together to form, to go after certain nutrients, to form the structures that they need inside the root to trade. So how do you reach consensus, right? I think this is sort of a really cool question that where Bitcoin comes in, because we're trying to understand actually how blockchain acts as a framework for how decisions are made in these very complex living networks, right? On the one hand, they're totally decentralized, but on the other hand, they need to be able to work together to become centralized trading nodes. And that's why I really wanted to ask Brandon about that. There's in some cases we do see the cooperation falling apart inside these fungal networks. How often do you see, the system that's supposed to work for decentralization and is supposed to work as a cooperative unit? How often do you see it breaking down? Where, let's say, a miner gets too much power or to actually change the way consensus works, right? Is it vulnerable at all to break down to cooperation?
Yeah, wonderful framing there, Toby. And I think one thing you mentioned, I just want to make sure I'm clear on is, so you said the left hand and the right hand, or there's essentially multiple different nodes in what we call a singular mycelial map. And each node in that network has slightly different genetic information, maybe a slightly different library of enzymes in which to attack or defend the network. And those individual nodes together somehow form consensus on, do we go over here? Do we go over there? Do we trade here? Do we trade there? And what I'm thinking when you say that is essentially pushes the complexity to the edge of the network where the nodes are interacting with their ecosystem in real time. And it's a good strategy because those nodes have the best information as they're interfacing in their little singular area. And so that's just as a strategy is much more effective than having a singular central processing unit, which then distributes orders. Did I capture that more or less correct?
Yeah, that's exactly right. Exactly right. But what I worry is that it still is vulnerable to breakdown in the sense that if you're out on the edge of the node, what you want to do is be reproducing. You still want those nuclei to get into a spore and to, to reproduce their copies. So maybe you send incorrect information back to the hub, let's say, where the information is processed. That's what we're trying to solve right now as scientists, is to try to understand what makes it. We want to know how decisions are made in these complex networks. But an even more basic question is, how can you be sure that the information being sent across that network is true, is actually honest information, is an honest signal? Because there is this vulnerability of networks to break down because those multiple nuclei, let's say, have their own self-interest at heart. And I think that's the sort of same vulnerability that Bitcoin is open to.
So to that point, although this takes us in a different direction, but a juicier, perhaps, direction than I was expecting, this gets into this question that I talked about with Arthur Brock on episode 83 of Future Fossils about Holochain, as a completely different crypto project, where he was saying that the idea of universal consensus, which you see in Bitcoin and you do not see in fungi, it's like the idea that a distributed ledger is going to carry an agreed upon universal record. Everybody's got the same history. That doesn't actually tell you, this is a philosophical thing, really, but that doesn't actually tell you what's true. That just tells you what everybody agrees is true. So the question, this is sort of like the deepest maybe layer, which is that the market doesn't tell you what something is worth. It only tells you what people think it's worth. And I think that that's ultimately a pin on which we can hang a lot of this conversation about ecology and economics, the context dependency of it.
Yeah, I can jump in here. I would love to. So, Toby, going back to the point about how do you know that the system will maintain the rules and form consensus when there's inevitably going to be disagreements between participants? So at a fundamental level, what Bitcoin is a software protocol, and individuals run the software, open source software, on their hardware, and that software communicates with each other through a gossip protocol, similar to BitTorrent or something like that. And so the individual, what's interesting about it is it's an opt-in system. Anyone chooses the software, and over time the software evolves and there's disagreements on the right way to change the system. And so each individual node chooses, do they want to upgrade? Do they like the new software, or would they prefer to stay on the old software? And so if, let's say, And there's been many historical examples where one group said we should focus on Bitcoin as a store of value, as more of like a digital gold or a savings account. And another group said, I think it's better that Bitcoin is more of a payment system for end users, right? So sort of a divergent path formed there. And the group then communicates on the social layer, and there's different signaling mechanisms at the node level to say what side you're on, et cetera. And ultimately, there was no consensus in the group. So what happened is the network actually forked, and two separate networks were formed there. And you can choose the rules that you support. And so that's always a constant threat in Bitcoin, is to fracture. However, what happened was the market quickly chose a winner. Right. There was like a 2-week period where people were unsure what's the right path. And then very quickly, all the economic value chose one path. And so there's sort of this precedent now where you don't want to be on the minority chain, because the minority chain loses all economic value. And so that's sort of at the node level. And you mentioned with the miners, I think the mining process in Bitcoin is very misunderstood. They should be more thought of as a service provider to the network. And they essentially do the accounting and they run security, to oversimplify. And in exchange for their services, they get paid in transaction fees and new Bitcoins being minted, which go directly to the miners. And the miners more or less break even. They barely make money because they have to find cheap energy, and they have the capital expense of buying machines in order to turn cheap energy into wages in the form of Bitcoin. And so I would just zoom out and say, the Bitcoin network is probably the most resilient computer network of all time. I anticipate this to be hundreds of years in the future. And it's simply based on your first comment about Bitcoin, which it's sort of this Franken technology of different units, different technological units that were discovered 10 to 30 years ago. And they come together to create this delicate balance of incentives where the individuals who have an economic stake in the network, they have an incentive to keep it going. And they have an incentive not to change the rules. And so there's kind of two things, right? There's the technical layer, which is essentially an implementation of what the consensus layer that humans think Bitcoin is. So there's a few fundamental rules, like there's 21 million units. Anyone can participate. No one can tell you that you can or cannot use the system, a few other things like that. And the rest is how humans interface with this technology. And so over time, it will change based on the needs of the individual. Let's say something happens where the network, some fundamental part of the technology breaks and Bitcoin's unusable. What's interesting is there is a ledger of who owns what. That's the most important part. That's sort of the ghost in the machine. So if the technology that Bitcoin is living inside breaks, you can just take the ledger of who owns what and migrate it to a new technology. From the beginning, it was designed to be indestructible, and we've seen so many cool examples of attacks here and there, and the system just routes around it. It learns. When it gets stressed, it creates a response through the ecosystem, and then individuals come and maybe they create a software patch, or a government's trying to ban it. So then they throw satellites in the sky. So now Bitcoin's not reliant on the internet infrastructure, or you can send ham radio transactions. And so the whole thing is built because the ultimate goal is to take money away from the state and give it to the people. And with a lofty goal like that, inevitably the state is going to want to intervene because the state feels that money is in its purview, right? It gives the state a lot of power. And so Bitcoin's full of redundancies. It's inefficient because of this. But I see very few vulnerabilities from the system breaking in terms of like people don't get along. There's just processes to solve those challenges, I guess.
That's beautiful. I mean, I really think what you described is sort of, evolution at its best. And I think one of the reasons why it works, why this cooperative system is so resilient, and basically you're saying that it has very few vulnerabilities, is because you started from sort of a top-down place whereby you could design the rules, right? I think the rules that you just described, and there's only a couple, and that's what really excites me, right? Sometimes it only takes one or two. But if you create these rules, then within those very specific rules, cooperation can flourish. And I think in that sense, that's quite interesting that you can prevent one party from gaining too much power within a decentralized system only by, for example, limiting the number of total Bitcoins that are in the system. You know, the rules that you mentioned, I think, are sort of the key to creating a structure that allows decentralized cooperation to flourish.
Yeah, you nailed it with regards to preventing political co-option. What we found throughout history is whoever controls the money ultimately takes an advantage from that at the expense of everyone else. And so because of the architecture, even if you owned a tremendous amount of the outstanding units, you have no unfair advantage over the system, which is very different with our current political system, where if you're close to the power center, you can change the rules. And we see this like 2020, for example, the stock market's at an all-time high. Simultaneously, unemployment's at an all-time high, right? That's due to political discretion. And I think it's important that we remove that from the money in the same sense that we remove religion from the state, right? It's just not the responsibility of the state. And to go back to your previous point about Bitcoin simple, that is such a profound point. It is simple. And detractors would say, well, it should do all these cool, funny widgets. And Bitcoin says, no, we're a heartbeat. We are a simple thing. It does simple rules. And from that simple starting point, that's how we can evolve and iterate through interfacing with the market. And I'd like to introduce Gall's law, which I'm sure everyone on this call are aware of, which essentially says if you want to make a complex system, you have to start with a simple system. And so Bitcoin is as simple as possible, stripped out all the complexity. And as long as it does that well, great. It performs a special function. And then what you can do is scale in layers, and you can bolt on additional networks on top that reference Bitcoin's rules in a sense that you have like cells, organules, organ system. It's kind of the same way with Bitcoin. And there's already a Lightning Network, which is in its infancy, but it's a peer-to-peer, infinitely scalable, kind of like a Visa network on top of Bitcoin is the simplest way. And so we're starting to see, starting with something simple and then the expansion, extending the functionality where that individual Bitcoin unit can leave its blockchain layer, play in some other network, and then eventually reference the truth machine, the arbiter of truth, which is Bitcoin.
So this is where I want to bring it down to earth a little bit here and ask this question about economic growth. Because one thing that I see when I look around at all of the living systems in this world as conventionally understood, the rainforests are these hotbeds of biodiversity, and yet they have boundaries. Going back to the example of cities and social relationships and scaling the pace of interactions, the more opportunities you have to meet people, the more chances you have to start a startup or organized crime ring or whatever. And it turns out that both of those things grow faster than the population because of the way that interactions grow faster than the population. Eventually, this cycle brings us to a point where in human society, the crises created by innovation start coming faster than we can perceive and respond to them. So like there's an innovation crisis cycle, right? Where every new crisis begets a new innovation, and this forms a ratchet that accelerates human societies to collapse. To me, it seems like part of this is because of the fact that we cannot actually accurately model the environment in its totality. Economics is always going to have externalities. And in fact, if you're trying to optimize for profit, you're optimizing for externalities. You're optimizing for the plausible deniability of theft in a way, because it's how can we make the most elegant, fewest rules possible, pleasingly simple explanation for what's going on that leaves out the messy complexity that we don't have to deal with, because the incentive structure in our economy of generating theories is not set up to punish us for outcomes that our models can't predict, because the outcomes exist over the horizon of the sensoromotor capabilities. I don't know if this is making sense, but it's like we can't model. How do I put this?
I think I'm tracking you here.
We're in a difficult position here as a species because, generally speaking, economically, the ways in which we measure profit and loss do not account for many of the things upon which the economy depends, but to try and bring those into the equation requires a massive increase, and we're seeing this in the sensors, in the computational resources,
in the attention that we give tracking all of these resource flows that then itself demands more metabolic input. And so in an attempt to map the world and distribute resources fairly, we're driving ourselves over the cliff, basically. Like, we are in a position where we know that as networks grow, the distribution, the whole bell of the distribution grows, and we see the extremes get more and more intense. I liked the comment earlier about stock markets and inequality, and stock markets aren't really measuring what they claim to be. But like, the point being that there seems to be a way that we are not accounting for something that evolutionary dynamics do account for in the Wood Wide Web and in mycorhizzal networks. And we see throughout the world that there are both decentralized networks, and you and I are all here like with heads on our bodies, and we are very much a counterexample to that. Likewise, inequality does seem baked in to some degree because it creates gradients that allow for, as you brought up, Toby, in your TED Talk, more inequality means more trade, means more opportunities for trade. So I guess here's what it boils down to. Looking back into the fossil record, is there a place, and I do not know the answer to this question, is there a place where you look at like whatever it was, like 380 million years ago or something, prototaxites, the giant fungi, the 6 meter tall sporulating, they thought they were trees at first, and then they realized they weren't. Why don't we see those anymore? I mean, it seems to me as though in order to be sustainable, mycorhizzal economies have learned something that human economies have not, and that Bitcoin has not yet learned. Go for it.
This is a great question. So you're asking, why don't we have these crazy tree-like fungi, right? I mean, so I'm not a paleontologist, so I'm not going to be able to answer that question very specifically, but I do think it brings up a really important point, and that means complex doesn't necessarily mean better. Right. And the arbuscular mycorrhizal underground market is the simplest in many ways that you can imagine. They're asexually producing, that's a little bit debated, but usually they're just asexual. They make spores. They bud these spores. They don't even have septate, which means they don't even have walls that sort of break the pipes up into sections. It's an opened pipe system. And we're starting to study the flows inside that open pipe system. And it's just chaos in there, right? There's nutrients that appear to be moving one way across a stream of nutrients that seem to be moving another way, the opposite direction. And they come to a junction. These nutrient flows come to a junction. And it's really hard to predict which way they're going to flow, right? Sometimes they go to the left, and then all of a sudden there's this oscillation, and you see these chunks sort of moving back in the other way. It is a mess, right? These flows. We don't even know what we're measuring at this point. But the main point is that they've survived for 450 million years using this system. They are responsible for plants to being able to come to land in the first place, right? Aquatic plants used to live in water with no roots. And, it was this partnership with these mycorrhizal fungi that allowed them to access resources from a very inhospitable environment. And we think that the rule is very simple. It's basically a tit for tat rule, right? Whereby you provide a certain amount and I provide a certain amount back. Now, of course, it's not always going to be like that. And, we see a lot of sort of complexities in terms of resource exchange at the interface. But I think the major take-home message is that complexity doesn't necessarily mean better for local marketplace trade. But when we're talking about a financial system that's supposed to cover, the globe, it's just a whole different level of scaling. And I think that's why it's kind of hard for me sometimes to answer these questions about, analogies between financial systems and these fungal marketplaces, because the scale is so different, right? We're talking about the scale of kilometers, centimeters, and usually what we're studying is the scale of microns, right? Really small. These hyphae are 10 microns across, and that's the level level we're studying the flows. So to be able to make comparisons then to the global trade market is difficult. But I think one of the things that actually really, comes through across all of the systems is that simple is better, and that there has to be some level of accountability. And to the less complexity you have, sort of the less vulnerable you are to breakdown. And maybe that's where Brandon can come in and talk about financial systems.
Yeah, I think that's beautiful framing, Toby, and I completely agree. And to tie it to Michael's point about he identified many serious problems with our current financial system, which I'll call an inflationary system or a debt-based economy. And in an economy like that, the government's constantly printing new money, and what it's essentially doing is borrowing from tomorrow. And what that means is always in the future, we have to create new money to pay back our debt. And that actually creates an exponential curve, and eventually the system breaks. And so there's essentially an embedded growth obligation in our current economy. And to tie it to Michael's point, that's a very human thing, right? Like no system in nature can grow inevitably. It will always break. And it's very human of us very full of hubris to think that we can manage an economy from the top. And we made an economy that is not in accordance with rules of nature, and that causes tremendous problems. And some examples would be because money is cheap or easily printable, it leads to the large players having access to money, and then they do silly things with it because they didn't acquire it at a fair price. And I know I'm speaking in a lot of economic terms here, but it leads to economic inequality. And we're at the late stage of that now. We're going to transition to a new financial system in the next decade. This is what the IMF, World Bank, WEF, that's what all the world leaders are saying, because we're at the end of another inflationary monetary cycle. And so I'm advocating for a deflationary monetary system, which is what Bitcoin provides. It's the antithesis to the inflationary system. And it allows for a slowing down of the economy, stop borrowing from tomorrow, incremental growth in ways that make sense. And it's actually a much more fair system because there is no political discretion. And I think that would reduce economic externalities, which Michael mentioned, such as not accounting for the costs of pollution or wrecking the environment or something like that, because you can't create fake value, which is what a fiat system does. And so it forces more accountability into the system, and it puts a strain on large actors who have political influence and forces them to be accountable to a fixed monetary system. That's a lot, but that's what I'm advocating for, is a money for the people that has all these rules in it that require, essentially just it restrains you, and it forces you to play by the rules instead of having some people with undue advantage.
Toby, you want to comment on that?
Yeah, I guess what I would say also is that, is the fungal network fair? Is any financial system fair, right? This is where we get into morals and things like that. And, I would say no, definitely not. The fungal network is also not fair, right? We've got these plants that are amazing because they don't photosynthesize at all. They're just pure parasites. They don't make carbon to feed the network, yet they feed on the network, right? But how big are they? They're tiny. They're these beautiful, tiny orchids that are white in nature. I guess what I'm saying is that there's boundaries to fair. It's never going to be fair, but I think that the rules that the underground market at least operates under means that organisms are always trying to rail against the restraints, right? Every organism is going to try to hoard resources. They're going to try to get as much as they can for the exchange of the prices, right? We're always going to expect that, right? Evolution predicts that behaviors are inherently selfish because this allows us to reproduce more. But it works because there's boundaries, right? And I think that is basically what Brandon is saying, is that there are ways to design financial systems with boundaries, that people are always going to fight against, but that ends up being a more fair and equitable system.
Yeah, it gives everyone, and you're totally right, there's no such thing as equality anywhere in the world. We just want to create a game that the rules aren't easily changeable. That's essentially the point here. It's to put a base layer on our human operating system that says, here's a monetary system that anyone can use The rules don't change at political discretion. And that allows everyone to participate and contribute as much as they can. And obviously individuals, some try harder, some are more motivated, some are more skilled, some have poor advantages growing up. So there's always going to be inequality. But the best thing we can do is remove political discretion and allow people to contribute. And one point on your orchids comment there, I forage a lot in the forest in Minnesota, and I always run into Monotropa uniflora, which is a fascinating organism. And I can't remember who brought this up, but they explained it as a hacker to the Wood Wide Web, right? They just latch on, steal resources, and try to get away with it.
Yeah, exactly. And that's what makes evolution, I think, so beautiful, is that they're always going to be the cheaters in nature, right? And, there are some rules to, perhaps to create the boundaries by which they grow. But essentially, everybody is trying to get as much as they can from the system. But there's this tension. There's always going to be this tension. But the tension creates a beautiful diversity of systems, right? It's the tension that drives evolution. So they shouldn't always necessarily be looked at as a negative thing. It really is a driver of diversity. And I think that's a point that has sort of been lost in this new language of the underground network being an altruistic, caring, sharing, let's help each other environment, because it creates a system that I think it's a false biology in the sense that there's more interesting dynamics going on. Even though it may appear as a cooperative system, I think there's some really cool hidden conflict dynamics that really drive the system.
Yeah, humans just can't help it but project our own belief system or anthropomorphize, or we see what we want to see, I guess.
Yeah, exactly. And I think there's, especially with this underground economy, there are questions that we can ask that may be useful to humans, right? The system is so different in terms of, the analogy really breaks down when we're talking across the scales at which these economies function. But, we can look at our system in the lab and we can ask, what causes economies to break down? How do small local markets evolve? Is there an optimal size? What is the ideal number of trading partners for market exchange? We can bring the economic system into the lab and we can watch specific trade strategies evolve under different conditions. We can study tipping points for when and how these relationships break down. And I actually think that that's sort of the most useful in terms of, people are always saying, okay, well, what's the point of studying, a plant fungal market? I think those are some of the important parts, is that it really allows us to study an economic system in the lab in the absence of cognition, and to see how information is moved across organisms and how decisions are made when you don't have a centralized system with a brain operating all decisions, but instead how decentralized systems can make decisions and make economies.
I love that last point. And I think piggybacking off of finding optimal trade partners, or essentially trying to predict or calculate how rational actors will behave in some sort of an economic system. And you mentioned how you can do that in a lab, and theoretically we can come up with economic principles in a small scale that might be useful to explore in a grand scale, maybe even through human economics. And I think there's a nice analogy here with Bitcoin, which is that the base layer, the blockchain layer, it is public data. And so you can actually see economic actors making decisions in real time. And it's created an entire new field of economics, which is essentially saying this is the first open economy in the history of time where we can glean information and run complex analysis on which person's doing what. And it's a very new field. But I think it will be a gigantic field in the future because we're learning exactly what happens and how people behave. And you can compare that with what is the price doing? Are the whales accumulating? Or is there more small people joining? How do they move flows around? It's kind of like a petri dish in that sense.
Yeah, and that gets me really annoyed because that's exactly what we want. Those are the data that we want, is sort of the blockchain history of how these fungal networks operate. And with our quantum dots, with these nanoparticles, we're just starting. It's such a different level of information. We can set up an experiment that takes us 6 months and get 7 data points, for example. And that's really really frustrating because what we want to see is this blockchain. We want to see how it's operating, how every decision is made. So one of the things that we're really pushing right now, which is just really the frontier, I think, of how we're going to study these organisms, is that we've built an imaging robot that basically is taking images now every 4 hours. So again, it's not the level of resolution that we want, but that's really, unheard of for studying fungal networks at this point. And it can do it to 40 networks simultaneously, taking these images. And so what it does is it allows us to stitch together the, at least the physical trade network of this symbiosis. And then, we can add all kinds of stimuli. We can add nutrient baits. We can see how resilient it is by cutting it with a laser at one point. We can increase the heat and see how that changes the flows inside, So we're getting an incredible amount of data, terabytes of data in a few days, just being able to segment networks like this. But what it does is it gives us a blueprint for studying behavior, because that's really what we need, is to be able to get enough data that we can see how decisions are made over space and time. And the only way to do that is just huge amounts of replication and data collection of complex networks.
That is so cool. And I appreciate your patience and willingness to go through these. I absolutely love the data coming out of what you're doing. I have nowhere near the patience to go through what you just described. But I guess what I found interesting there is you're essentially taking a snapshot of the architecture of the mycelial network at points in time, how it responds, right? That's sort of the mission here. Am I right about that?
Exactly. That's exactly. Yeah. You should come and try to argue for my grant applications for me. But not only are we studying the architecture in response to these external stimuli, but because, our microscope is on this sort of known coordinates, we can then go in and take moving images of the flows inside that trade network at the same time. So basically that allows us to not only get the architecture of the trade network, but hopefully the commodities moving through the network, quantify the carbon and phosphorus moving through the network at the same time. So that's really the goal, is to be able to link the flows inside the network to the physical architecture of the trade network itself.
Amazing.
That reminds me of this question regarding the use of tokens. Now, this is not like a particularly like a Bitcoin thing, but this is a crypto thing, right? The idea that you can tokenize value, you can represent something with a cryptographic asset, say 1 cubic unit of carbon dioxide or whatever. And there are people like Regen Network that are actually working on crypto applications for ecosystem services in this way. So I'm not breaking new ground here, but okay. So thinking about this and thinking about what you've written, Brandon, about how Bitcoin unlocks stranded resources, that I'd like to put this all in the context of the history of life as an engine constantly discovering new sources of energy and nutrients for its metabolism. Olivia Judson has written about this extensively, about like 5 energy epochs when life discovered fire through the glycolytic metabolism after the great oxygenation event, that we turn waste products into fuel. The economic forces driving all of this look for ways to, for better or worse, quote unquote, extract value from absolutely everything. And so I'm curious about your thoughts on what makes that process sustainable rather than squeezing everything dry. What prevents that kind of a process that becomes more and more intelligent from undermining itself by commodifying something, isolating it from its, like the horn of a rhinoceros, as a ground into powder as magic. And it's like, you're not, that has value, but you're not thinking about the rhinoceros's place in the ecosystem that you just removed it from. And I feel like arguably all value is that way, right? Value is based on a model of the world that is by definition incomplete. And so how do we keep these things, these processes that are excellent at creating, identifying value, supposedly making value where there was no visible or economically recognizable value before. How do we uplift the network of interdependencies that already exist in nature into the economy with the relationships intact, rather than severing them and creating new networks of dependencies based on fiat assignments of value. Does that make sense?
Yeah, I mean, if we talk about, ecosystem services and tapping into some of these relationships, some of these symbioses to help us with future climate emergencies, I think what's most pressing for humanity, I have a hard time believing that we're not talking about this all the time, is how the loss of something like these fungal networks will affect the phosphorus cycle. Right. I mean, it's estimated that within 20 to 30 years, that demand for phosphorus is going to outpace supply. This is a big problem that people really aren't talking about. Phosphorus is a finite resource that's necessary for all life. So while we can never make more phosphorus, these fungal networks, they really allow plants to access forms of phosphorus that are otherwise unavailable to them. So as phosphorus becomes more and more scarce, plants in both agricultural and natural ecosystems are going to increasingly rely on these underground fungal networks to access this non-renewable resource. So if these fungal networks are destroyed, access to the source of phosphorus is lost. And I think, to me, this is a call to arms, right? That says that this is something that's survived for 450 million years, that's been such an integral part of ecosystems. What we see, obviously what's below ground, but also animal and plants above ground as well. To me, the loss of these networks that's what I'm most scared about, right? There's no time to lose these guys, right? Especially because we're using phosphorus up at such an alarming rate. So we're going to become more dependent on these networks, I think, in the future.
Is that tied to just an over-reliance on industrial agriculture, where we have to extract phosphorus as some sort of a fertilizer and just dump it all over, and then it washes into the rivers and then the oceans? Is that our problem here? Like, if we redo agriculture in a sense that it's more regenerative, or bring back the grasslands in the American West, or like, how do we prevent that from happening?
I mean, I think that, the same ways that, sustainable agriculture have been practiced in the past, we just have to, make that at a larger scale. When we add lots of fertilizers to agricultural lands, the networks actually stop functioning, because their role in an ecosystem is to collect resources and trade them with plants. If the plant roots have access directly to phosphorus and nitrogen, they don't feed the fungus to get it. So basically, the fungi are not getting the food that they need, and they can't make spores, they can't reproduce. And so when you look at a field that's been fertilized, for decades with high intensity phosphorus and nitrogen, you're not going to find much of a fungal network there. So basically, if you really want to support the fungal networks, you give them just enough resources that the plants are very dependent on them. But it's not just phosphorus and nitrogen. They provide so many benefits in terms of carbon storage. I think it's something like 5 billion tons of carbon are transferred every year from plants to underground fungal networks, right? So if you lose those fungal networks, you're also losing this massive carbon storage capacity. Soil erosion, right? It's a huge threat to global change. But soil erosion is controlled when these fungal networks, they produce really special compounds that make soils, I guess, more sticky, right? Then they form these aggregates, so they hold together. These underground networks provide so many solutions that if there's one sort of champion, I think, of climate change, it's these guys.
That makes total sense. And an analogy came to my mind, which is that if we artificially include NPK into a agricultural environment, right, that's kind of like creating a trust fund baby, in the sense where now the system doesn't need to, it has no incentive to produce these for the plants. So they sort of atrophy and they get lazy, and then they lose their own ability to do their role in the system, which means that it relies on external inputs in the form of artificial fertilizer. I think that's fascinating.
Yeah, exactly. There's some plant species, whole families of plants, like the brassicas. So that's the broccolis and the cauliflower. These guys don't form the relationship with the fungi anymore. They've lost the ability to actually form the relationship. And that's not necessarily because of agriculture, but these plants are known to grow in really high nutrient areas, right? They're very good at colonizing new habitats with really high nutrients, and they don't need the fungi. So it can be costly to form this relationship. So they stopped forming it. And so I think, what worries me is that if we see a move towards that in the future, with more plants sort of abandoning that symbiosis, it's going to break down, and it breaks down in really high nutrient environments. And as a result, it's not just the relationship that's lost, but it's our ability to control soil erosion and to store carbon underground. All of these things are knockdown effects.
God, that makes me wonder if Bitcoin is not itself the result of economic inequality. Like it's just like a symptom of it. And that if under conditions where affluence was a little bit more easily guaranteed, that these circuitous workarounds wouldn't even exist, you know?
Yeah. 100% right. Like the planet or just the human species is not liking the financial system we're in. So Bitcoin is sort of an immune response to a broken system. And it came with 30 years of work from scientists and cypherpunks trying to build this thing. And it came out in 2009, right at the point when the global financial crisis came. Yeah, it is an immune response at the perfect time. And to Michael's point, we would not need a Bitcoin-like system if the economy was working great. And so it is a response, and I think it's the right response. It's gaining tremendous momentum in the nick of time, and it makes me optimistic about the future. Without it, young people see no hope in the future. They're disenfranchised. You're seeing that right now with the whole GameStop, Wall Street bets, the little guy versus the hedge funds fiasco in the US right now. It's the same with tensions with BLM and tensions with all these different protests. And so young people are disenfranchised, and Bitcoin does offer hope, and it does offer a potential solution to transition, right? Because the system's going to break, and every time it breaks, it causes more inequality and more problems. And so, yeah, I see it as sort of a life raft into a new system, and it's not perfect. The transition will be chaotic, but we're going through the transition no matter what. And so I feel optimistic having this tool that can make the transition smoother. And it works as humans form symbiosis with this thing at the individual level, at the city level, state level. It works at all levels. It sort of reduces the economic fallout of a broken system, and which would reduce suffering and reduce problems, which could theoretically reduce physical conflict.
Brandon, just a quick question about that. I mean, is that the Bitcoin that we see today, or is that the Bitcoin that it could grow into? I mean, if Bitcoin was built on this idea of facilitating, transactions, enabling trade, has it achieved that? It seems like it's amazing. It's storing value, right? It's like your own Swiss vault, right? Which you can keep value in. But at this point, is it more about speculation than transaction?
Really important point. And what I would say is historically, when a new monetary good enters a system, it goes through an evolutionary process where it starts as a collectible. It's just interesting. And then it transitions to something more like a store of value, which is where Bitcoin is. It's kind of a proto store of value today. It's still small, it's still volatile, etc. And then longer term, as theoretically the population adopts this thing and it's more widely distributed, there's more economic value stored in the network, then it will make more sense to use for transactions. However, if we look at it, the future is here, it's just unevenly distributed. If we use that framing, people in the West, we don't really need Bitcoin today, right? We have the benefits of a stronger, relatively financial system. We have banking services, et cetera. However, in countries like Argentina, Brazil, Cyprus, Venezuela, Nigeria right now, areas where there's countries or the state is crumbling, financial system's crumbling, the people on the ground there are actually using these tools to pay for things and to store value and to preserve their capital or send their capital out of their state's purview. And so it's kind of a yes and. Like from the macro space, we're nowhere near using it to pay for coffee. I predict at least a decade before that's even rational. However, depending on your economic circumstances, you can use this tool for many different ways. And so, yeah, you're definitely right. It's small, it's emerging. And the picture I paint is an optimistic future where Bitcoin continues its path. And I see no reason to think that that wouldn't happen. In fact, I think that it's accelerating. And with the current financial breakdown coming from a pandemic and our response, et cetera, I think that makes Bitcoin more valuable. And so I think people are starting to wake up for this. All economic metrics and sentiment metrics are trending in the right direction. So I feel optimistic that the picture I paint will come true. However, there's always risk.
The stock market really did extremely well during the Spanish flu. So I don't know that that's a property of Bitcoin in particular. I would love to keep talking to you both, and I'm just super grateful to have the opportunity to talk to both of you. And I hope that sometime in the future, I'll get the chance to talk to you both again when I feel like I'm in top form and we can really get into the details a little bit less haphazardly.
No, it's great. Thank you, Michael and Brandon. I had a really nice time, and it's a great podcast. Thanks so much.
Thank you.
Yeah, I really appreciate your time, guys. Super fun, stimulating. I've got a lot of little rabbit holes to scurry down after this.
Exactly. I spent a lot of time taking notes, so we'll see what happens after this. So thanks again, Michael.
Thanks again for listening. Future Fossils is an independent, entirely listener-supported program. If you believe in the work that I'm doing and you want to help see it thrive into the unimaginable future, then you can avail yourself of all of the backstage goodies at patreon.com/Michael Garfield. Or you can just reach out to me personally at Michael Garfield on Twitter or Instagram. Have a wonderful eon.